Welcome back. This is John P. Kelleher from Los Madonnas College, and I'm talking Fire 102, Section 0109 for our online class. And we are at week 12. 12. Which way is right? Week 12. In any case, we're going over hazardous materials. Hazardous materials is a firefighter's nightmare. There are times when you may have to try and mitigate and help a problem. For instance, a overturned truck or something like that, where a hazardous material is released, whether it be on a freeway, a street, at a hospital, whatever it may be. Firefighters have to deal with hazardous materials. Okay, the definition of a hazardous material, noted from the Title 49 of the Code of Title 49 of the Code of Federal Regulations, CFR 49, states that a hazardous material is a substance or material that has been determined to pose an unreasonable risk to health, safety, or property when transported in commerce. Some other people call it a substance that jumps out of a container, or when something goes wrong or hurts or harms the things that it touches. So hazardous materials are bad. Hazardous material events do not occur often, but when they do, they should be taken very seriously. Examples of that is the Walnut Creek pipeline release. I think that was back in probably like mid-90s, maybe late 90s. The HazMat fire at Chevron, biggest fire I've ever seen, 90-foot flames. Unbelievable. 3 a.m., 90-foot flames. And then the General Chemical release in Richmond, that was another one. That was probably, both were in the early 2000s. Early 2000s maybe. I told you about the official definition of Title 49. By the way, people, you may have to take notes on this, or you may have to pause. So I'll give you that because you don't have a PowerPoint to back it up. So when you do, you'll need to see it again. So if you want to pause it, I'll let you know. I'll go slow, or I'll say, I want to pause here. The official definition, pausing. The official definition for Title 49 of the Code of Federal Regulations, CFR 49, states that, as I said before, a hazardous material is a substance or material that has been determined to pose an unreasonable risk to health, safety, or property when transported in commerce. Know that. The Chemical Abstract Service, CAS, has published that there are over, know this, 6 million types of chemicals out there. This information is based in probably the 90s, so it could be 6, 7 million now at this point. In order to simplify the vast number of chemicals, these compounds have been divided into 9 separate hazard categories or classifications. The 9 categories or classifications. These categories are designed as United Nations hazard class numbers 1 through 9. So know them. When they talk about the hazard classes, UN hazard class numbers 1 through 9. 1 through 9. Yeah, 1 through 9. The hazard class name will be 1, explosives. 2, poisonous gases. 3, non-flammable compressed gases. Oh, I'm sorry, take that back. Hazard class name is explosives, and the hazard class UN number will be explosives, be number 1. Poisonous gases on the hazard class name, poisonous gases, that will be a hazard class UN number 2. The non-flammable compressed gas, that will also be hazard class number 2. A flammable gas is also a hazard class number 2. A flammable liquids, that goes hazard class UN number 3. Flammable solids, that's hazard class number 4. Or liquids is 3. Flammable solids is 4. Flammable liquids is 3. Solids is 4. Oxidizers or organic peroxides, that's hazard class of 5. Poison and infection liquids and solids, that is 6. Poison, infectious liquids and solids, that's 6. Radioactive substances, radioactivity, that is 7. Corrosives is 8. And then miscellaneous dangerous goods, those are 9. That's 9. So again, 1 through 9 is your hazard class UN number. You see it on a placard. That's in the lower part of the box. I'll go over that later. 50%, know this, of all hazardous materials released are flammable gases, liquids, and solids. Half of all the hazard release materials released are flammable gases, liquids, or flammable solids. 25% of all hazmats are corrosives. Okay, so know that. We'll go over placards and all the first responder checklist. I'll go over that at the end. But right now I'm just going over some information. I'll also go over DOT placards, all that kind of stuff with the hazard class numbers. I'll go through the whole process. So just what we're talking about. Other regulated materials, know this, ORMs. Other regulated materials are classified into 5 categories. Know what an ORM is, other regulated material. ORMA is anesthetic, irritating, noxious, or similar property. An example is chloroform, foam, camphene, trichlorethylene. ORMB are materials capable, when wet, of causing significant damage to a transportation vessel or vehicle. Example is ferric chloride, copper chloride, or calcium oxide. ORMC, materials unsuitable for shipment unless properly identified. Battery parts, excelsior, sulfur, fish meal. ORMD, smaller container commodity amounts of certain materials, like a flammable liquid or corrosive liquids, is in 1 pint amounts. And then ORME is some hazardous weights, i.e. polychlorinated biophenols. So in this case, know what ORMs are, and are classified into 5 categories, A through E. How should we handle the hazardous material incident? We'll go over the checklist, like I said, later. What are your DOT placards? I'll go over that in just a sec. Who should we always use at least 2 references? Okay, know this. You should always use at least 2 references whenever you deal with hazardous materials. 2 references. That means you use some type of books or references when you're dealing with some type of product. Know that. So always use at least 2 references for any hazardous material incident. Examples of a reference. NFPA 704 warning system, which we'll go over. The ERG DOT guidebook, we'll go over that too. MSDS, material safety data sheets, much more detailed. MSDS, material safety data sheets. Those are usually at the location, and they'll have much more pages on what the product is and what it concerns. Those are MSDS sheets. And then lastly, know this one, call Chemtrek if you're not sure. Chemtrek is open 24/7, 365 days a year. Call Chemtrek, 1-800-CHEMTREC, CHEMTREC, Chemtrek. Call Chemtrek only for emergencies. Don't be calling them just, hey, I want to check you guys out, what's going on with Chemtrek. This is only for emergencies. They won't treat you right, trust me. So if you have an emergency, these are different type of references, material. The NFP 704 warning system, I'll go over that. The ERG DOT guidebook, I'll go over that very soon. MSDS, which I will not do, the material data safety sheets, material safety data sheets at your location. And then also Chemtrek, it's another reference. CHEMTREC. If you all call Chemtrek, it's 1-800-CHEMTREC. CHEMTREC. Okay, so we'll go over the DOT guidebooks and the ERG later. How do I identify what the product is? What are we looking for? We look for shipping papers. Shipping papers should be on board any mode of transportation. Any mode of transportation. So if the mode of transportation is a highway, the name of paper that you're looking for the product is the bill of lading. Bill of lading will be on highway. The location, usually in the cab of the vehicle. If it's a mode of transportation is railroad, it's going to be on a way bill or cargo. And that's usually the possession of the train crew member. If it's a marine or ship, the name of papers will be the hazardous cargo manifest, and that's the holder of the bridge of the vessel, holder on the bridge of the vessel. And if it's of an aircraft, it's the air bill. The name of paper is the air bill, and that's in the aircraft with the pilot. So again, any mode of transportation, highway, railroad, marine or ship, and aircraft. Highway is bill of lading, railroad is way bill or cargo, marine or ship is hazardous cargo manifest, and then aircraft is air bill. And they're all looking at these different locations to find out what this product is. Some definition and terms relevant to hazardous material incidents. I'm going to go over some that we haven't seen, but they should be on some of the listings you have. the definitions we've gone over before that you have submitted. I'll also put some stuff up on Canvas, some pictures, some stuff to help you out with different placarding and such. I'll put that up on Canvas as well. Pyrophoric substances. Pyrophoric substances. Materials which ignite spontaneously in dry air or at temperatures below 130 degrees Fahrenheit. So pyrophoric substance. An example is dimethyl zinc, tributyl aluminum, selenium gas, phosphorus trisulfide. So pyrophoric substance is a material which ignites spontaneously in dry air or temperatures below 100 degrees Fahrenheit. Carcinogenic substances. Carcinogenic. Materials capable of producing cancer in animals and humans. So carcinogenic is anything to do with materials producing possible cancer in humans or animals. Examples of those is benzene, asbestos, polychlorinated biophenols, PCBs we call it. Teratogenic substances. Teratogenic substances. Materials capable of producing birth defects in animals and humans. Mutagenic substances. Mutagenic are materials capable of producing genetic changes in animals and humans. So know your carcinogenics and your pyrophoric substances for sure. We went over that. You have a definition of specific gravity. Example, water being 1, gasoline being 0.8. So it's lighter than water, specific gravity. Kerosene is 0.8, so that's lighter than water. So what's that going to do? Is it going to sink or is it going to float? So if it's lighter than water, what's it going to do? It's going to float on top, right? If it's heavier than water, like hydrogen sulfide, it will sink in water, right? So that's your specific gravity as compared to water, the weight of water. You know that one. Vapor density, same thing, only as the weight of it as compared to air. So air is 1.0. Ammonia is 0.6. So that means it's lighter than air, right? So what's that going to do? It's going to float in the atmosphere, right? Very important. Chlorine, 2.48. That's heavier than air. So what's that going to do? That's going to sink. And methane is 0.55. Are we concerned with vapor densities higher, lower than air? Not that much, because they'll dissipate. They'll go into the atmosphere. The ones we worry about are the ones that are heavier than air. And those are sink low, and they stay the ground. And where do they find? They find an ignition source. If they ignite, that's a problem. Vapor pressure, we talked about that. That's hydrogen sulfide at 20 atm. Boiling point, we know what that is. The temperature at which vapor pressure of a liquid equals atmospheric pressure, 14.7 psi. Flash point, we talked about flash point. The minimum temperature of a liquid at which gives off vapor sufficient to form an ignitable mixture with air. It needs an ignition source for ignition to occur. Example, gasoline. Ignition for flash point of minus 36 degrees Fahrenheit. That means it will ignite if it's minus 35 degrees Fahrenheit. Still ignite if it finds the ignition source. Kerosene, 110 degrees Fahrenheit. Ignition temperatures is the minimum temperature at which a substance must be raised before it will ignite. So the minimum temperature to which a substance must be raised before it will ignite. Combustible liquid, we know what that is. A liquid with a flash point above 100 degrees. Flammable liquid, a liquid with a flash point below 100 degrees. Flammable range is that ratio of vapor to air in which range ignition can occur. Is it too rich? Is it too lean? Remember going over that. Lower explosive limit, LEL we call it. The minimum concentration of vapor to air mixture for ignition to occur. The lowest amount of air mixed with a liquid. Example, gasoline, 1.4%. Kerosene is 0.7%, and hydrogen is 4%. So that's your upper explosive limit, lower explosive limit. Your upper explosive limit, the maximum concentration of vapor to air mixture for ignition to occur, the highest amount of air mixed with the liquid. So again, when we talk about gasoline, in order for the gasoline to explode and get that piston to fire, the spark plug being the ignition, you have a mixture of liquid, gasoline, and air, and that creates like an air pocket. It hits that spark of the spark plug, fires, and then pumps up the piston in the car. So that's reality of what they talk about: lower explosive limit versus upper explosive limit. Lower being too lean, upper explosive to being too rich. Upper explosive limits maximum concentration of vapor to air mixture for ignition to occur. The highest amount of air mixed with a liquid. Examples, 7.4% of gasoline versus air. And the kerosene 5%, hydrogen's 74%. Okay, so you need, if it's 1.4% gasoline fuel and air mixed with air, that's a very low LEO. If it's 7.4% mixture of gasoline with air, that's its upper explosive. Gets any higher, it's too rich to fire, if that makes sense. Expansion ratio, the determination of how many volumes of gas or vapor produced by the evaporation of one volume of liquid. Example, liquid oxygen, 860 to 1. LPG, liquid petroleum gas, that's 250 to 1. Know these two items, deflagrate and detonation. Deflagrate, very fast combustion, up to 3,300 feet per second. That's that explosive nature. So deflagrate is very fast combustion. It's up to 3,300 feet per second. Detonation is explosion at which speeds above 3,300 feet per second. So deflagrate versus detonation, explosion at speeds of 3,300 feet per second, and deflagrate is very fast combustion up to 33 feet per second. Okay, so deflagrate and detonation. Now I'm going over what they call the first responder checklist. I think I'll probably send this out to you I'll make a copy, send it out to you, and put it on Canvas. First responder when they're dealing with HazMat, first responder incident checklist is, are you upwind? Are you upgrade? Are you in a safe location? Upwind meaning what? You're upwind, okay, meaning your way. Is wind blowing to your face? No, upwind meaning if the product is over there and the wind is blowing to your face, that means you're upwind from it. That means you're breathing it in. You want to be downwind of it. You want to be away from it. So wind at your back, as they say. The wind at your back blowing away from you. Okay, the product is blowing away from you. Downwind, not upwind. Upgrade, meaning are you at higher elevation? Are you down below? You're down a lower elevation. Okay. Have you isolated the area? Isolated means the big thing in hazardous materials is isolating the area, identifying the product. Okay, so isolating the area is you want to make sure the area is safe. No one's in the area. So if it's on a freeway, you want CHP to close all the roads, east and west, okay? Block the area. People get upset about it. But if you have a liquid spill, you got to isolate the area. You got to close it off. So that's isolating the area. Are you going to establish command? We talked about incident command system, right? Establish command. You're going to report on conditions. You're going to let everybody know coming in. You're going to protect your people. Consider evacuation. Do you need to evacuate the people, get out of the building in this case, or do you want to get them, what they call shelter in place, where you keep them in the building? What are we doing now during this COVID virus? We're sheltering in place, aren't we? We're staying in place. We're not going evacuate. We're not getting out of there. That's the difference. Know the difference. Consider giving direction to incoming units. So if you have a downwind product, you don't want them coming in on Elm Street, coming down, that's downwind. They're going to breathe in that bad air, right? You want them to go around the product so they don't breathe in that bad stuff. Notify the appropriate agencies and request assistance. Can you identify the real problem? Is there a fire? Is there a liquid or solid spill? Is there a vapor release? Is container leak? Is there potential BLEVE? Remember BLEVE? Boiling liquid, expanding vapor explosion. Don't want that, right? Can you identify the products from the DOT placards, which we'll go over in just a sec, or labels, the NFPA 704 system? These references we're going to talk about very soon. Pesticide labels, shipping papers, inventory lists, MSDS papers, responsible party. Is there someone there, the driver of the truck? Is there someone there that knows about this product? The type of occupancy, the type of container. Can you determine the risks? Are there people, environment, property? Who's at risk here? The people, environment, property, or all three? And then will there be need for rescue, getting people out of there? Medical treatment? Do you need AMR? Do you need some medical assistance? Decontamination. That's what you guys are as firefighters. You'll be what they call FRO, first responding operation, first responder operations, where you're going to probably be doing decontamination, which I've done in my past, where you basically have pools and you spray everybody off to decon off out of the area. Is there containment? Are we containing the area that's product? Do you need to evacuate, I said? Have you provided modifying conditions, command and control, alternate plans, and extended operations. These are all different things during hazard materials. Now, the key thing about handling HazMat, which I've learned and I've seen it, is it's a long process. It's not a fire. You're not running into the building and put the fire out. You really need to take a step back. Just like when we talk about hazard materials, or just when we talk about different types of incidents where you really have to take a step back and slow things down. Okay? There's something I want to talk about with the class per thing is we call E.G. Fopper Company, which I did back in the Fire Academy, and we'll call about the classes. And then most hydrocarbon gases are heavier than air, except for ethylene oxide, acetylene, hydrogen, ammonia, methane. These are all different products, okay? But I'll go over that in just a second. Okay, so now we're going over what they call the United Nations 4-digit, United Nations 4 different identification number. On that number, when hazard materials are transported in cargo tanks, tank cars, portable tanks, there's a 4-digit United Nations UN identification number. It must be displayed on a placard or an orange panel carried in conjunction with the appropriate placard. So here's your placard. Right here, this little square thing. Okay, that's your placard. When remember about the UN number, that's that number down below right here. It's the number right here, that 3. Okay? Then they're going to have a 4 and what they call 4 UN number, and in this case 1090. Okay, 1090. That's your UN ID number. Very important. Or you're going to have what they may have the color. It's going to be flammable, or they'll have a little picture like that of flame, so you know it's a flammable. 3 being flammable. These are all on your placard. Okay? I'll also send this picture here of domestic placarding. Here's all your different setups from 1 to 9. Okay? And again, as you see, from 1 to 9 is 1 right here being orange, and that's your explosives over here. 2, your poisonous gas. Okay? 3, your flammable gases. And then your oxide is your chlorine. Okay? That's your number 2 over here. And then going across oxygen, flammable. And then again, there's your little number down below. 6 being poisonous gas, 7 being radioactive, 8 being corrosive. These are all on the bottom of the placard over here. Bottom of the placard. There's your 8. There's your 7. Okay? And then the UN number is that 4 number. The 4 numbers right over here. Okay? Down here. And I'll get that copy. I'll send that out to you guys via Canvas. Okay? So that's your placard number. Another type of reference is what they call the NFPA, National Fire Protection Association 704 warning system. National Fire Protection Association 704 warning system. There's 4 sections, okay? I'm going to go over each one. Usually you'll have these locations like at a hospital. They'll be designated like in a park outside the parking lot, and you'll see the NFPA 704 warning system. In this case, as I mentioned, you have those 4 numbers, right? 4 square. It's a square just like a placard, okay? You're going to have 4 sections. Each section will have what they call, the first one over here is your blue section, and that's concerning your health hazard. 4 being the worst in all this. If it adds up to 12 and there's overreaction, that means it's bad stuff. So in this case, on the right side, they'll be in blue, and it'll be health, okay? Blue section, and 4 being the worst, and that says requires special protective clothing. Extremely dangerous, wear full protective clothing. That's number 3, okay? So that's your health hazard. Then down over here on top will be your flammability in red, flammability. How flammable is it? 4 being the worst, 4 being extremely flammable gases and very volatile liquids, okay? 3 being ignites at normal temperatures, and 2 being ignites when heated. So that's 2 up here, your flammable section. And then back over here on this side is yellow, and that's your reactivity. Your reactivity is 4 being may detonate at a normal temperature. 3, it's strong shock or heat may detonate use. In this case, 2 being possible violent chemical change. And then lastly, last bottom section is your special hazard in white. And right there we'll say in this case, on the bottom, all these different insignias, right up top we'll say a W with a cross in it. That means it's water reactive. this case, it has oxides, OXY. Down below is if you see the radioactive picture, it's a radioactive hazard. EXP is explosives, okay? These are your special hazards. So if all these add up to 12 and you have a W with a line in it, that's bad stuff, okay? So that's your 704 hazard system. I'll give you a picture of that. Okay, and then my last section, we're going to do this as a group. We're going to go over what they call your biggest resource in the fire service, your DOT Emergency Response Guidebook. Department of Transportation's Emergency Response Guidebook. This is year 2000. I have many copies I'd probably give you guys as a class, but we don't have that ability. So in this case, I'm going over it to you on video. So this is 2000, but I just saw the ones in 2020. They look very similar to this, only they probably have more stuff, okay? So that case is, you notice the book here, all right? Has one on every engine, probably has it on every truck, okay? Just to see what type of bad stuff is out there. You notice on the book, there's all these different sections and colors, okay? If it's in yellow, it's a yellow section. If you look at it in yellow, okay? You see in yellow, sorry. See that in yellow? It's the product, so you have the UN ID number by the number first, okay? The number first. So let's do one, let's see. Sodium. So sodium has, its number is on sodium is 1428. 1428 on sodium. I don't know if you can see that or not. Sodium 1428. Next to sodium will be what they say, a guide number. Okay. There'll be a guide number on it. Okay. Guide number right here. And that'll be a highlighted big number. That's your guide number, how you're going to handle it. We'll talk about it in the book. Then on the other column, it'll say the name of material. So it matches the number to the name of the material. Okay? And then that's just the yellow section. Your blue section, if you know the name of the product, it's all in alphabetical order. So if you know the product, like in this case, what do we say was sodium? We're going to go alphabetical, so we're going to go to the S, sodium. Look up S. There's sodium right there. It's in blue. There's sodium. And right there, sodium has 1428. 1428. You guys can see sodium there. Okay? And then you'll see the guide number, coordinated guide number will be, in this case, sodium. Your guide number will be, for sodium, it will be 138. So there it is right there on the bottom there. Okay, on this side. Okay? And then you'll see I have a guide number, and then you have your guide number. So in this case, guide number for sodium says 138. Right there. I don't know if you can see that or not. 138. So I'm going to turn the page to the orange section of the book. The orange section of the book. The orange section. And you're going to look up the number 138. There's the guide number 138. Okay? See the guide number 138? And that's going to give you very important information. It's going to talk about potential hazards. Potential hazards. It's going to talk about public safety. It's going to talk about protective clothing. It's going to talk about evacuations. So that's the stuff we're going to say, okay, in this case for sodium, the fire explosion may produce flammable gas or contact with water, may ignite, contact with water, moist air. Runoff may create fire or explosive hazard. Health, for health hazard, irritation, contact with vapors, substance, may produce corrosive solutions. Fires will produce irritating, corrosive, and or toxic gases. And then public safety, call your emergency response telephone number on shipping paper. Isolate, spill, or leak, immediately at least 50 to 100 meters. That means isolate, block off as best you can, away. Protective clothing, what would the firefighters use? Protective clothing, your PPEs, your personal protective equipment. Wear positive pressure self-contained breathing apparatus, your SCBA. Structural firefighters' protective clothing will also provide limited protection. And then if it's an evacuation, they'll have two things, large spill and small spill. If there's a large spill, consider initial downwind evacuation. Downwind Evacuation 250 meters or 800 feet. If it's a fire, if it's tank fire, rail car, isolate 800 meters or half a mile. If it's also consider initial evacuation for in all directions. So that's your guidebook in your orange section. Okay. So again, and then lastly, on special hazards, your green section of your book, very top bottom of your green section will talk about, you can read it here, will be table of initial isolation and protective actions distances. Okay? So those are for special items. For instance, let's say chlorine. We're going to look up chlorine, right? So chlorine, under chlorine, we'll look up in blue, and chlorine will say, oh, actually, we have a drill here, right? We have a question. All right, we'll use this question. A tank car containing a material placard with number 1040 is on fire. What sights or sounds should cause an immediate withdrawal by personnel? So we look up 1040 in our book. We don't know the name of it, so we go to the what? The yellow section. So we look up 1040. And 1040 is right there. Did you guys see that? 1040. 1040. 1040, and the guidebook is, the guide number is 119P. If it has that highlight, what's that mean? You got to go to the very back in the green section. That's that special situation, okay? So 1040, the product is called ethylene oxide with nitrogen. 1040 is ethylene oxide with nitrogen, okay? And again, if it's highlighted, that means we got to go back to this green section. That's a special situation. So the question is, first of all, we identify it as ethylene oxide. What is recommended? What sights and sounds should cause an immediate withdrawal per safety personnel? Withdrawal immediately of rising sound or venting safety devices. What is the recommended evacuation distance when a truckload of explosives seizes on fire? Evacuation distance. So we're going to go the guide number for ethylene oxide, which is 119P. Guide 119, that's my orange section, okay? And it's going to say health toxic, fire explosion, flammable may be ignited by heat. Contact with the acid liquid may cause burns. Protective clothing, we got to wear protective SCBAs, PPEs for us as firefighters. Evacuation on a spill. See the table of initial isolation and protective distances, the one section in green. For non-highlighted substance, increase downward direction as necessary. If there's a fire, if there's a tank, rail car, tank involved, isolate for 1,500 meters or 1 mile in all directions. Also consider initial evacuation for 1,600 meters, 1 mile in all directions. So it says go to the initial isolation protective action distances, and that is that green section here in the bottom. So we're going to go to 1040 in the green section, and we're probably going to answer some more questions there. And 1040 in the green section will say, there it is, ethylene oxide with nitrogen, okay? It's going to say in this column, first isolate 30 meters or 100 feet. If it's a small spill, then protecting if it's a day situation. If it's a spill, we're going to isolate initially what? 0.2 kilometers or 0.1 miles. If it's nighttime, we're going to go 1.1 miles, maybe different. Protect, and that's isolate day or night. Then if it has a larger spill, it's going to say, if it's a larger spill, we're going to say half a kilometer in the daytime. Or initially, we're going to go 200 feet. But if it's a large spill, half a kilometer or 0.3 miles. If it's nighttime, we're going to go 1.1 miles. Okay? So that's a special situation if that product is highlighted, like these ones are. If they're highlighted like that, you're going to go back to the green section. Okay? So yellow, white, okay, and then front. What's cool about the front page in white is it goes over what the tank cars look like. okay? Whether it be pressurized, semi-pressurized, what a truck will look like, okay? We'll also go over placards. Okay, there's your numbers, ID numbers. We'll also go over the pictures of your placards, okay? In different sections, okay? And there's your placards, right? Again, I'll send that out to you. I think that's about it. I just wanted to give you a rough kind of a breakdown of what HazMat materials are about, your GOT guidebook. And like I said, I'll make pictures and put them up on Canvas, so you can go buy it. I've given a quiz. You should answer most of the quizzes based upon what I say. You may have to stop this lecture to go over just what exactly if you're writing down too quick, to answer some of these questions on the quiz. If you have any problems, let me know. Please text me. Okay? That concludes week 12, and that concludes this lecture for Fire 102. Okay? See you at the oral presentation. Be well.